So today I'm going to talk about what we find at Adidas when we wanted to use the remote weight storage. So let me introduce myself. I'm Alejandro Cespedes. I work at the platform engineering team at Adidas in the technical monitoring team. And that means everything metrics related. But before starting, I would like to ask you a question. So what do you see here?
See my creativity.
See my creativity.
Regarde-moi créer.
Jumping Chwangi.
See my creativity.
So you just saw a bunch of people doing sports, right? Yeah. So let me show you what we see at Adidas, okay?
See my creativity.
See my creativity.
Regarde-moi créer.
Jumping Chwangi.
See my creativity.
So as you can see at Adidas, we are quite obsessed with data. And we try to measure everything and at different layers. And not only on the technical side, but also on our business processes. And we try to apply all those metrics that we gather everywhere we can, okay? So first, let me put you a little bit in context of our landscape. We run several Cortex clusters around the world and serving tens of apps in each cluster. And that means millions of time series in each cluster, and we have to monitor the cluster itself on top of that. And on top of that, the growing usage of both the monitoring stack and the Kubernetes cluster itself is growing inside our company. And the way the infrastructure is provisioned means that we cannot grow a big Prometheus as much as we can. So we have a limit. And when we hit that limit, Prometheus crashes out of memory. So good luck. We have a professional football player giving us advice. And so if we run no central Prometheus, no team can break your Prometheus. Because sometimes it's not just only the usage, but mistakes are made. And, cards IDs are put as labels, and cardinality explosion means Prometheus explosion. So we decided to change and ask teams to run its own Prometheus. But there is an issue with that, and one team's metrics are valuable for another team. For example, the team that's managing Prometheus, Kafka, offers some metrics that are valuable for another team that's using Kafka. For example, they want to be alerted if the certain topic is getting records pile up and things like that. So you can imagine. So we found ourselves with lots of Prometheus that wanted to send metrics somewhere and have a central view on that. So we look in the open source for solutions to that problem that we have. And we found Cortex, we found Influx, also InfluxDB, Thanos, and also recently VictoriaMetrics. But which one to use? That was a question that nobody could tell us. If you ask the Cortex guys, obviously it's Cortex. And if you ask the Thanos guys, obviously the answer is Thanos. So we created a plan and we tried to benchmark these solutions, but we tried to do it in a different way. We didn't want to see how much they were going to accept, or how many metrics they were going to accept before exploding, because that's not a point where we wanted to run the solution. We just wanted to know how many CPU is going to take for our metrics, how much memory, and how much is going to cost us to store those samples, okay? So from those 5, we divided in single tenant, because we can treat each team as a single tenant, and we can put a storage on top of that only for one team, or we can use something like Cortex for which its multi-tenancy capacities, and have one big cluster with infrastructure shared between the different teams. So for the single tenant, we chose Influx, Thanos, and VictoriaMetrics, and we gave them some resources, and then we set up an avalanche, and then we let it run and see how much of those resources that we gave them they were using. So this is what we found when we send the 500,000 time series, which more or less in our environment, it's a small team, and we wanted to test that. These are numbers. Probably if you run your own test, the numbers will be something different. Probably they will be similar in some aspects, especially in the bytes per sample. This is we included the index size for that, because it's not only storing the samples, but also the index that matches to that. And we wanted to, how much will it cost us to completely store that? And then we look at that, and we saw that the InfluxDB was eating too much memory, but we wanted to test for a much bigger team. So yeah, InfluxDB was crashing because out of memory errors. And then we set with pretty much as much load as the previous test. And as we can see here, the difference with the previous test shows us that not every software scales the same way. And yeah, that's a fact. Yeah, so those are the results that we got in the single tenant. And then we decided to do the multi-tenant. And for that, we wanted to set it up in a different way. Again, we wanted to completely over-provision, and with shared infrastructure, we've been running a shared infrastructure before. It's Prometheus in its Kubernetes cluster. And you don't want to run shared infrastructure without protection, because if one single team can break your infrastructure, your solution, you are in a bad position when that team makes something wrong on a weekend, and nobody is there to help you. So we completely over-provision these things. We set up 2 distributors and 4 ingesters for Cortex, 7 InfluxDB nodes, 2 inserts and 4 storage in VictoriaMetrics. And also, since the VictoriaMetrics in the single instance, we've successfully been able to send lots of metrics, we set it up with 2 different instances. And yeah, we have 2 teams that were willing to put their production data. And these teams weren't the biggest ones, because those weren't so up to. So yeah, let's go to the results. So these are the results. With Cortex, you can store the data in DynamoDB or Bigtable, or also in Cassandra. Also, you have the option to store the index data in DynamoDB and the chunks in S3. And one thing with all the cluster software is that they have lots of levers that you can pull, and we didn't want to start playing and wanted to know that deeper it's, because we were just testing the waters. If we just wanted to know if they were suitable for our use case. Okay. And what we found, if you look at the InfluxDB, the memory usage is huge. And I don't think it's fault of the InfluxDB itself, but rather the way the software is run. And if you look at the load that we were putting into the system, this was completely over-provisioned for the load, and probably the usage will be very similar if we send 3 times as much load as we sent. So pick these results with a big pinch of salt. Okay. Yeah. Also, one thing to note is the Cortex DynamoDB, because in the end that means money. So it's not only the CPU and memory that was being used, but also the DynamoDB in our case. That also have to be amounted for the total cost. So these are our results. And one of the things that I wanted to share is that it was quite easy to set all these solutions. I remember testing Cortex 1.5 years ago, and the documentation was lacking, and it's been a huge improvement since the last time we looked into that. So as you can see, this well, not you can see, but as you can imagine, the world is moving super fast. These solutions are evolving super fast. It's one in one direction, and I encourage, if you are interested in running one of these systems, to run a similar test for your use case, because it's not that much work to set it up, and you can learn a lot about this software, but also about the way it's your software, your teams. In our case, our teams, but in your case, it could be different. The usage of the Prometheus that they use, because one of the things that we learned is when one team was deploying one application, they were recycling all the pods at once, and that caused 2 times the ingestion rate was the same, but the number of active series was twice the amount of that, and that increased the memory usage at that specific point in time, and for 5, 10, 15 minutes, depending on how the rollout was. Okay, so that's all I wanted to share, and if you have questions, happy to.
Right then, thank you, Alejandro. So we have plenty of times for questions. Could have had longer at lunch.
Go on then.
Well, this hand was up first.
Thank you. So, writing only one part of the story, do you test actually reading and all the performance with regex and all the stuff?
This test was only on ingesting, and we explicitly avoided testing reading, because we found out that it was quite difficult to characterize each team's usage. Some teams were having lots of dashboards in Grafana, and they were reloading constantly. So other teams were doing quite complex queries where they were aggregating several data, and we just wanted to focus on the ingestion part without taking into consideration the reading part. So you are right, and I encourage you to do that test with your data, because the way our teams read data will be very much different than the way your team does it. Thank you.
Hello.
Hi.
I just wanted to start by saying thank you. Like, that must be really nerve-wracking to speak to like the author of Cortex, the author of Thanos, like Rob from M3 is here.
Yeah.
So I want to start by saying thank you very much. Like, thank you.
Thank you.
And now for a real question.
Okay.
What was the replication? What was the replication factors you configured?
We removed the replication factor because VictoriaMetrics cluster doesn't have replication, and we wanted to account for that.
Okay, cool. Thank you.
Pointed question.
Anyway, I believe Rob hasn't actually made it here yet because of... Oh, he's here now, right. Okay. Just so he can defend himself.
Hi.
Hi.
So as you deployed the Prometheus for all your teams, I suppose it was deployed to Kubernetes then as containers, not as virtual machines externally.
Yeah, that's correct.
Okay, thank you.
Also, we have in our on premises, we have some legacy applications that run on virtual machines, and we support that. We give them a package to deploy Prometheus there, and also on AWS EC2 instances. Some applications aren't ready to move to Kubernetes, and we provide them some packages to help them start with monitoring in those scenarios. But yeah, this test was for Kubernetes.
Yeah, hello. Have you tried to compare the solutions in terms of operability and which is simpler and which is harder to operability for your team?
Yeah. Thank you. Very good question. Yeah, I try to avoid those statements, because what it may be easy for me may be hard for you, and something, or for a different team, people, it could be medium difficulty. If you know a lot about Cassandra, maybe you will have an easier time setting up Cortex with Cassandra or InfluxDB, regardless of the Thanos or VictoriaMetrics. So it's not everything performance that matters. It also depends on the context of your team, because if your team has certain skills in a certain software, why not exploit that? So yeah, I cannot tell you it's fast. I can tell you what was easier for me or harder for me. As I said, Cortex 1.5 years ago was not the easiest part, but nowadays it was a lot easier than 1 year. So, yeah, it's an answer that's hard to it's a question that's hard to answer. But thank you.
There's another hand there somewhere. There we go. You're ready in for it now.
Thanks, Brian. Yeah, Rob here. I work on M3. So yes, I am here. No, I wanted, echoing Tom, really appreciate going through, running a test is
I was
quite
trying
difficult.
to be fair to everyone.
Yeah, totally. And it's impressive. Actually, my question was basically, what do you think would be a fair way for, a reproducible test that others can run? I'm not a huge fan of the timescale one, to be honest, because it's bulk loading. I don't think that's very representative of a metrics workload. I wanted to hear your thoughts on what you think.
Yeah, that's one of the things that I was asking myself, because, for example, the bytes per sample metric, that will depend heavily on the data that the teams are generating. So I don't have that ability myself, because it depended on a different team, and it was their production data. They cannot fake it, or so maybe it would be good to have some data that's going to be representative of the real world. But how do you create that data set? It's going to be tricky, because I think that will be the first part to be reproducible, is to have one data set that's always the same for everyone. So the way we set it up is it was this Prometheus. We're writing the same samples to the 4 systems. A bit of the disclaimer: remote write takes some amount of memory, and it's not a trivial amount. And it depends on the number of shards, and for each remote queue is times the number of shards for that queue. And in our case, the memory usage for those Prometheus were close to 2 times the usual. So, thank you. Thanos, I guess.
No. So each of these solutions involved running and ingesting Prometheus anyways, right? So have you considered not using any of these technologies?
Yeah, so you mean the Thanos without the receiving part?
Or just plain Prometheus and just keep and have large disks, basically?
Yeah, we consider that, especially with Thanos, without the receiving part. But the problem was our on-prem legacy applications, because similar as the previous talk with the security focus setup, each team is running in a secure subnet, and opening ports and everything was a nightmare, or maybe not a nightmare, but something that we didn't want to work.
That makes sense. Thank you.
You're welcome.
Yeah, I know just how bad my throwing arm is, so I'm keeping it short.
Thanks. You consider two classes of systems, the single tenant and multi-tenant. Why you considered it, and do you use in production both systems, the single and the multi-tenant, and why you use it?
Okay, so the first question, we separated because there are some metrics. We are at Adidas are kind of open by default internally, but there are certain metrics like number of orders or amount billed or something like that that you don't want everyone to see, because that's kind of confidential. And yeah, so for that reason, we have to keep each team's metrics separated from each other. And then what we do have is a global view based on proxy that you can opt in as a team for being part of the global view. For example, the Kafka team. It's not something super secret that has to be kept dark. So those metrics are open for everyone to see and consume. Okay, thank you. And was there a second question? Or
I think you answered it. You use both in production, I think.
No, actually, we only are going to use, because we haven't fully migrated yet, the VictoriaMetrics cluster. But that's the plan. The thing with, remember the part where I said you don't want to run shared infrastructure without protection? Meanwhile, in the project, the context changed, and suddenly we have that protection automatically done for us via Kafka, because in Kafka, each team was having strong quotas in place, so they couldn't overload the system with lots of samples. So for that reason, we decided to move to a shared infrastructure.
Next question. Time for another few. But we get Alfred set up as well. Any more questions? Oh, yeah, okay.
Thank you. Just very briefly, I'm curious, what would you think if somebody suggested that you use Kafka as a remote storage backend? In my book, it's no such thing as a stupid question. So
No, it's not a stupid question. We use it for buffering, and also we use it for another purpose, but it's just protect. We are not using it as a remote storage, because you will have to implement the query layer on top of that. So it's not only storing the data, but also making it available.
Thank you.
For those standing around, there's plenty of seats in the middle just there, because we've got a few minutes still to the next talk. Next question. Put your hand up, get a box thrown at you.
Hi. I want to ask you, obviously, which one you choose. I guess you mentioned that you have chosen VictoriaMetrics, and whether this was the only metric you used to pick the winner. And if you choose the VictoriaMetrics, do you consider also the user base volume, the number of contributors to those projects and other criterias?
So the question, I guess, is did we consider the risk of going with one solution over the other? Because Thanos and Cortex are part of the CNCF and have a much bigger developer communities, I guess. So that's kind of the question, right? Yeah. So we did consider, but that doesn't. The risk is lower, but you don't get any warranties that Grafana Labs is going to keep investing on that, or that Uber is going to keep investing on InfluxDB. They are a business and they put resources where they see fit. And for the foreseeable future, they are going to keep investing, but there's no strong guarantee on that. So.
I have a question, if you don't mind.
Yeah.
So one of the other things to consider when you're looking at any remote storage, beyond just can it handle the load reading and writing, is it actually producing the right answers? As I know in the past, like I remember some issues in M3 were fixed with regexes, subtle stuff. In fact, Alfred and his team found a bug in Thanos and just sent a PR, which will hopefully be merged soon to fix that. Very subtle issue. Took me quite some time to realize it was there. Like this sort of thing is there. Like, have you done anything to check that, you know, these data are right? Because like if I'm seeing bytes per sample that are very different between databases, that makes me wonder, are we losing information, or, you know, is there other weirdness going on?
So we didn't fully test that the data was guaranteed to be there. We did some just surface scratching that some data was there, and there was the same data that we were sending. So we didn't, no strong guarantees on that.
Okay, we might just, if it's a quick one, yeah, you've got 10 seconds.
Follow up with this type. I mean, some of the databases actually use compression that is lossy.
Yeah.
So one of the ways you save space is you actually have lossy compression.
Okay.
Did you actually look to see if you were getting the same results that you were getting out?
As I said, no.
Okay.
So
it's something to look at because it's easy to save storage if you do lossy compression.
So we did some, as I said, just some little test on that the data was there, but I cannot tell you that X solution wasn't losing data or losing resolution and precision there.
Oh, thank you, Alejandro. Here is your spoon.
Oh, thank you.